Petrified Forest National Park. Located in northeastern Arizona, roughly 100 miles east of Flagstaff, Petrified Forest National Park is known for colorful fossilized logs preserved for hundreds of millions of years in the ever-changing environment of the area. In addition to petrified fossils, the park is also home to ancient Native American dwellings, some of the best preserved in the United States, and a variety of flora and fauna that have adapted to the distinctive climate of the area. Unlike some other national parks previously covered on this channel, the tectonic plate history of the Petrified Forest area is not particularly vibrant. What makes the area unique is the fact that hundreds of millions of years ago, during the early Triassic period, the area was covered in water, flowing downwards from mountains in the north to lakes and swamps in the south, and was home to a virtually unimaginable diversity of plants and animals. The flow of water, and its eventual recession during the later Triassic, shaped and colored the area by depositing alternating layers of varied sediments on top of each other. Due to the different sedimentary deposits in the park, the Painted Desert, the area home to less petrified logs and more mountains, is divided into members based on how old the exposed Chinle Formation is. The Chinle Formation is the name for all of the layers of sediment that cover the area. Multiple well-known deposits rise out of the formation, such as the 230 million-year-old Mesa Redondo member, characterized by red, purple, and orange hues, the 228 million-year-old Blue Mesa member, named for the blue, purple, and green hues of its sediment, the 227 million-year-old Sonsella member, colored slightly grayer hues of blue, the 213 million-year-old Petrified Forest member, colored red and brown hues, and the 205 million-year-old Owl Rock member, colored orange and light red. Covering the Chinle Formation is the more recently formed Bidahochi Formation, the result of more lake sediment as well as volcanic eruptions around the area. The volcanoes mostly deposited ash in the area and fewer chunks of igneous rock. The Hopi Butte, a nearby area of volcanic rock, is the best known deposit of such rock, helping to stop erosion of sedimentary layers. Erosion is not necessarily bad as it uncovers fossils, but is an ever-present phenomenon that changes the landscape positively and negatively. Several small rivers currently run through the park, feeding primarily into the Puerco River, which runs through the middle of the park and divides it into northern and southern sections, and, to a lesser degree, feeding into the Little Colorado River. The southern section of the park is home to the famous fossilized logs. The swamplands that existed during the Triassic period in the area of the park were densely populated with plants and animals. When those plants and animals died, their remains were left behind. More often than not, those remains decayed and left nearly no trace. However, a large amount of plant and animal matter was deposited underneath sediment, which compressed the cells. The organic material in the cells was gradually replaced by inorganic substances, mostly quartz, which preserved the cellular structure but not the contents. The rich color of the logs in the park comes from metallic compounds within the silica structure. The black color can be connected to carbon, which is likely found in an allotrope of its elemental form, or iron sulfide. Green hues can be connected to a number of metals, commonly copper and iron, as well as chromium and nickel. Red hues can be connected to iron, most commonly oxides of the metal. Blue hues can be connected to copper and cobalt. Purple and pink mark the presence of manganese. Manganese can also manifest as black and yellow colored material when oxidized. In different compounds, metals can take on more than one color. Some logs have also been found to contain gemstones, such as citrine and amethyst. Bentonite, the silt material making up most of the area's dunes, has interesting properties when exposed to water, expanding and flowing downwards, and contracting when drying, causing cracks in the ground. These cracks make it nearly impossible for plants to grow in this soil, and as a result, areas of bentonite are prone to erosion by weather. Weather in the park varies dramatically by season. In the summer months, average temperatures during the day hover around 32 degrees Celsius, and during the night can dip to 15 degrees Celsius. During the winter, daytime temperatures average 10 degrees Celsius and nighttime temperatures can dip below zero. When cloud cover is not present above the park, daytime and nighttime temperature can vary greatly. Most precipitation in the park occurs in the form of rain during the late summer, although snow during the winter is not uncommon. Frequent winds can pick up dust, creating sandstorms. Analyzing the fossils of plants and animals found in the park area has given scientists knowledge on what kind of environment existed in the area hundreds of millions of years ago. Most of the logs come from the now extinct Orocarioxylon arizonicum species, although 8 other tree species have been identified as well. Many species of plants and animals have been identified from fossils, among them reptiles and ferns that indicate that the area was once a tropical swamp. Modern plants and animals in the park grow in a hotter and drier environment than their prehistoric counterparts and have accumulated adaptations to suit this environment. Both plants and animals have to make good use of the dry daytime conditions while also surviving the cold nighttime conditions. Since the flora and fauna share this environment, they often implement the features of other living things to aid their survival. Most plants in the park are lichens, with 233 documented species, followed by grasses with 167 documented species. Lichens are largely beneficial organisms to other plants due to their ability to fix nitrogen from the atmosphere into a more usable form. In addition, lichens are good at absorbing water from the air. Lichens are commonly found growing alongside larger plants and sometimes on petrified logs. Grasses are an important food source for animals, as well as an important obstacle to soil erosion. Larger plants, such as flowers, shrubs, and trees, are found more rarely throughout the park, although flowers become significantly more common after periods of high precipitation. Plants have many features that let them survive in the Arizona desert environment. To reduce evaporation, many plants grow with special coatings on the stems or leaves. Leaves tend to be smaller in size to decrease evaporation while still allowing the plant to harness sunlight. Plant root systems spread out in 2 ways, sideways just under the ground to immediately absorb rainfall and deeper downwards to absorb groundwater. Some plants have the ability to hibernate during long droughts and continue metabolism once conditions become favorable, including the seeds of those plants. Other plants are adapted to simply withstand the droughts. The park also hosts a variety of animals, ranging in size from insects such as beetles to mammals such as mule deer. An estimated 300 species of animals exist in the park, a large number of them birds that migrate in and out. Smaller animals feed on plants, and subsequently larger animals feed on smaller animals or plants. The animals' interaction is largely dictated by the regional climate. For example, during daytime in the fall season, lizards may lie on rocks to warm themselves, allowing predators to hunt them. In order to avoid the heat and potential predators of daytime, some animals are nocturnal, meaning they are active at night. Examples of symbiotic relationships, relationships in which 2 organisms coexist and benefit one or both of the organisms, exist throughout the park ecosystem, one example being birds eating grass seeds, which benefits the bird in terms of food and benefits the grass in terms of moving seeds to another area for them to potentially grow. Invasive species threaten native species in the park by forcing them out of their habitats or making their habitats uninhabitable. One specific invasive species, the tamarisk, is able to excrete salt from water it absorbs back out of the plant, making the surrounding area deadly to most other plants. 57 of the park's plant species are thought to be invasive, and it's reasonable to assume a large number of the park's animal species are also invasive. Invasive species can potentially destroy the ecosystem of the park beyond repair, and the National Park Service spends millions of dollars trying to combat them. The park region has a long history of human habitation, and remains of human life are abundant and well preserved throughout the park. When humans first entered the area approximately 10,000 years ago, the climate was very different from what it is today. Temperatures were lower, precipitation was more common, and flora and fauna were more abundant. Paleo-Indians, the first visitors to the park, hunted animals like bison, often using petrified wood to create arrowheads, many of which have been found in good condition. As the area became hotter and drier, and many large species of animals migrated or went extinct, humans were forced to settle and find new sources of food, often plants. Starting around 8,000 years ago, domestication of plants and animals began, and people began building small shelters and tools from available material in the park. Farming soon became prevalent, with most people growing corn, squash, and beans. However, people still often supplemented their diets with animals, such as rabbits. Artifacts from this time period include houses made from petrified wood and ceramic pottery. Living conditions became unfavorable due to decreasing precipitation, and many natives moved to other areas. Francisco Vázquez de Coronado is believed to be the first European explorer to have reached the area, leading the Coronado expedition through northwestern Arizona and meeting the native tribes along the way. Spanish expeditions following Coronado further explored the American Southwest, looking for paths to connect their Pacific coast colonies to those along the Rio Grande. One of these Spanish explorers named the region Painted Desert after the sweeping colorful dunes he saw. Following American acquisition of the southwestern territories from Mexico, American explorers came to the area of Petrified Forest in search of a route to the Pacific. One of those explorers, Captain Lorenzo Sitgreaves, first saw petrified logs nearby, and another explorer, Amiel Whipple, recorded the petrified logs and the Painted Desert region of the modern-day park in an expedition log. With increasing travel to the area came the necessity for a road to improve transportation. The initial route was a wagon road, which was finished by 1857 and continually improved for 3 years, after which it was abandoned. Homesteading became common, and cattle grazing arose, harming the grasslands near and in the park. With the arrival of a railroad close to the park region in the 1880s, towns and hotels quickly sprang up in the area, promoting tourism to marvel at the intriguing stone forest. Tourists and homesteaders became a problem for the area, as cattle grazing threatened to ruin the regional ecosystem, and tourism depleted the petrified forest due to tourists taking pieces of logs as souvenirs. Conservationists like John Muir argued that the petrified forest should be preserved for science. An attempt to preserve the petrified forest was made in 1895, but was rejected by Congress. In 1906, Theodore Roosevelt created the Antiquities Act, and through the act, created Petrified Forest National Monument, covering only part of the area of today's park. In 1916, the National Park Service was created and tasked with protecting and managing national parks and monuments. Federal workers created and improved infrastructure within the park, including building roads and residences and repairing Native American dwellings. During this time, the famous Painted Desert Inn was constructed, later to be purchased by the National Park Service. The monument was expanded, and in 1958, Dwight Eisenhower approved the bill to make Petrified Forest National Park, completed in 1962 under President Kennedy. Today, Petrified Forest National Park is a popular destination for paleontologists seeking to research well-preserved fossils, as well as regular tourists simply admiring the petrified logs. Unfortunately, theft of petrified wood continues at a significant rate. Park rangers offer programs to people of all ages to learn more about the park. Thank you for watching, and as always, if you enjoyed, click the like button, favorite the video, share the video with your friends, or subscribe for more educational films. Check out some of the other videos on this channel for more educational documentaries, or check out the featured channels for more content.